right now we're going to go into an introduction on descriptive statistics. In general, we're going to be talking about graphs. Graphs are commonly used to organize, summarize, and analyze collections of data. Using a graph to visually present a data makes it easy to comprehend and to describe the data. Here's an example of raw data. Raw data in this case represents student information. We have, and this table is right from your textbook, it's table 2.1 in the text. The keys here are sex for the student sex, male or female, HR for study hours per week, GPA, the grade point average, CR, the number of credits, and MAJ for major, and that could be categorized in LIB, BUS, CMP, SCI, HTH, or FPA. And notice that we have rows and rows of student data. So for example, the very first row we have a male who's a liberal arts major, 15 study hours per week with a GPA of 2.79 and 14 credits this semester. Okay, we call this raw data because it's not yet been arranged in any useful manner that can be analyzed using statistical techniques. Like an egg that hasn't been cooked, raw data hasn't been analyzed yet. It's simply been collected and displayed, and that's what we're looking at right here, a collection of, or rather a display of collected data. However, if we take that data and we organize it in something more useful, for example, this bar chart, we have a quick and easy way to come to conclusions about that data without having to analyze it ourselves. So what we're looking at here is a bar chart where female is represented by the darker color and male by the lighter brown color, and frequency would be the number of students. So this bar height indicates that there's about a little bit more than 40 students in our collection that are female liberal arts majors, and this bar represents the fact that we have about 25 male students in our data collection that are liberal arts majors, and so forth. We have the other majors as well: business, science, health sciences, computer or mathematics, and fine and performing arts. A variable is a type of information, usually a property or characteristic of a person or thing that is measured or observed. For example, a variable among people could be weight, height, eye color, gender, GPA, or body temperature. Each of these are different variables. The value of a variable is a specific measurement or observation for a variable. So specifically, one person could have the values 220 pounds, 6'2", blue, male, 3.8, 98.6. That would be the particular values for the variable for one person. A data set is a collection of several data pertaining to one or more variables. So what we were looking at on the page with all the raw data of student GPA and credit hours and major, those would represent a data set. We have several variables for each of the students, and we have the values associated with those variables. Okay, there are two types of variables. There are categorical variables and numerical variables. A categorical variable represents categories and is non-numerical in nature. For example, a student's major, liberal arts, math, science, those are categorical because the answers to those questions are not numerical. Okay, eye color could also be a categorical variable, because when you ask a person their eye color, the answer to the question is a color, not a number. A person's nationality, the type of vehicle a person may drive. Who's your American Idol favorite? Are you a Met fan? All of these answers can be categorized by values that are non-numerical. On the other hand, numerical variables are variables where the value is a number that results from a measurement process. So, a person's height, a person's age, the number of credits per semester that the person is taking. These are all numerical variables. Numerical data can be further classified as either discrete or continuous, depending on the numerical values it can assume. So we're going to break down numerical variables into discrete or continuous variables. Discrete data are numerical values that can assume only a limited number of values. Okay, so I know it's confusing, just hold on. An example of discrete data: the number of full-time students at Nassau Community College, the number of unemployed people in a city, the number of car accidents in a state in a given year, a shoe size: 5, 5.5, 6, 6.5, 7, 7.5, etc. The number of children in a family, the number of eggs that a hen lays. Okay, each of these are countable values. You can count how many full-time students are at NCC. You can count the number of eggs that a hen lays. Another example would be the number of leaves on a tree or the number of houses on a street. These are all values that can be counted. On the other hand, continuous data are numerical measurements that can assume any value between two numbers. For example, the amount of milk from cows is considered to be continuous data because a cow might yield an amount of milk that can be any value between 0 gallons and 5 gallons. Let's say 5 gallons is the max. It would be possible to get 2.343115 gallons because the cow is not restricted to discrete amounts of 0, 1, 2, 3, 4, or 5 gallons. Continuous data are the result of some measuring process. So if you have a very precise measuring tool, you could measure to the precision of 2.343115 gallons. Because there are an infinite number of values between 2 gallons and 3 gallons, and for that reason we say that the amount of milk from cows would be considered continuous data. In fact, any volume measurement would be considered continuous data. Okay, continuous variables are height, weight, distance, length of any kind, temperature, blood pressure, or volume. Consider how you can measure each of these values and get an infinite number of values between any two discrete numbers, like 1 and 2. For example, if you think about height, a person can be 5 feet, they could be 6 feet, or they could be an infinite number of possibilities between 5 and 6 feet. There are an infinite number of heights between 5 feet and 6 feet, so height is considered a continuous variable. Okay, so here's our breakdown of data. All data can either be considered categorical or numerical. The categorical data were those that had questions that could be answered with non-numerical answers, like eye color, nationality, major. Each of those are categorical variables. Numerical variables have number answers, and they can be broken down into either continuous or discrete. The continuous are those like height, weight, volume, distance. Each of those are continuous. Discrete, on the other hand, are those that only can assume particular values, like the amount of eggs a hen lays, 1, 2, 3, or 4. The number of children in a family, 0, 1, 2, 3, 4, etc. Those would be discrete values. Okay, there's an exercise here, example 2.2 from your text. For each of the following, identify each variable and classify it as either categorical or numerical. And if it's numerical, further classify it as either continuous or discrete. Okay, so there are 11 examples here. Take a minute and pause the video and see if you can categorize these 11 examples as either categorical or numerical, and if they are numerical, classify them as either continuous or discrete. Okay, let's go over these examples. A person's height. Person's height is a numerical variable, and it is continuous because height can take on any value. For example, the example I gave before, between 5 and 6 feet. There are an infinite number of heights between 5 and 6 feet, so we consider it continuous. An individual's political affiliation, for example, either Republican or Democrat, that would be considered categorical. The number of rainy days in July. How many rainy days were there in July? Well, that is numerical and discrete because we can count the number of rainy days in July. We either have 1 rainy day or 2 rainy days or 3 rainy days. There aren't 2.5 rainy days. It either rains or it doesn't. So that's how we categorize rainy days. Number 4, the number of gallons of fuel used to travel from New York to Chicago. Similar to the amount of milk from a cow, this is a volume question, therefore it's numerical and continuous. There are infinite number of gallons between 10 gallons and 11 gallons, for example, and therefore we have continuous data. A person's hair color is categorical. An opinion to the question, is the President of the United States doing a good job? That's also categorical. A shoe size. This is an interesting one because shoe sizes versus foot length are two different things. The length of a person's foot would be considered numerical and continuous. However, a shoe size is numerical and discrete. And the reason is because shoe sizes can only take on half sizes and whole sizes. For example, you have size 5 and size 5.5, size 6 and size 6.5. There aren't an infinite number of shoe sizes between 5 and 5.5. Shoes only come in half sizes. And so, because of that, we say shoe size is numerical and discrete. The number of inches of snowfall per year, that's like thinking of a person's height. That's still a distance measurement, and so that is numerical and continuous. The number of vowels in a paragraph is numerical and discrete. The amount of soda in a 2-liter bottle, that's a volume question, so that's numerical and continuous. A student's credit load for the semester is numerical and discrete. Okay, student's credit load for the semester. At Nassau, we do have half-credit classes, but we're still restricted to have credit loads that are marked either on the whole or on the half. So you can have 10 credits, you could have 10.5 credits, you can take 11 credits, you could take 11.5 credits, but you can't take an infinite number of possible credits between 10 and 10.5, for example. It's either 10 or it's 10.5. So that is the distinguished the distinguishment between categorical and numerical variables and continuous and discrete numerical variables.